Conductors. Some conductors conduct better or worse than others. Reminder, conducting means a material allows for the free flow of electrons. The flow of electrons is just another name for current. Another way to look at it is that some conductors resist current to a greater or lesser extent. We call this resistance R, capital R. Resistance is measured in ohms, which is noted by the Greek symbol omega. How will resistance affect current? In real life and in some physics problems, conducting wires have resistance in them, which we will learn more about soon. However, a lot of the time, we will pretend like wires don't have resistance. Instead, we will be adding resistors to our circuits to change the amount of current going through them. Here is the symbol for a resistor in a circuit. Raising resistance reduces current and raising voltage increases current. We can combine these relationships in what is named Ohm's law, I equals V over R. Current is directly proportional to the voltage difference, so the bigger the voltage of the battery, the more current there will be. And current is inversely proportional to the resistance in a circuit. So if we increase resistance, we decrease current. The unit for current is the ampere, which, as we learned before, we had charge over time. That was coulombs per second. Amperes are also volts over ohms. Raising the resistance in a circuit reduces the current, and raising the voltage increases current. However, this relationship is linear in only what we call ohmic materials. So in an ohmic material, if you graphed out voltage and current, so I equals V over R, so therefore if we have voltage on our y-axis, we would have V equals I, R, and current is our X. So I'll write this like this. So this is our Y over here. This current is our X. So therefore Y equals mx. This is the slope of this line. So the slope of that line would give us the resistance. However, if the relationship is not linear, for example, if you take experimental data and you find this relationship, then you are dealing with a non-ohmic material. Draw a simple circuit that has a 9-volt battery with a 3 ohm resistor across its terminals. What is the magnitude and direction of the current? All right, so there's going to be many ways to draw this out, but I will draw it like this. Here's our battery. It's 9 volts. Our resistor is 3 ohms. And what is our current? Well, we're going to use Ohm's law. All right, the voltage difference between here and here is 9 volts. The total resistance in the circuit is 3 ohms. And in this case, as in most cases, we will assume the wires have no resistance, and we're only going to include this 3 ohm resistor. That gives us 3 amps of current. So here's another drawing of a battery with 1 resistor. Conventional current flows out of the positive terminal, which is the longer line. It enters the battery at the negative terminal. And here's Ohm's law giving us 3 amps of current. Calculate the electric current in a wire of resistance 4.5 ohms when the applied voltage is 18 volts. So here's one way to represent this. You could also think of this like one wire that's a resistor all the way around. Either way you want to visualize it is fine. The battery is 18 volts. The resistance is 4.5 ohms. What's the current? Well, we're going to need Ohm's law. The voltage difference on one side of the wire versus the other is 18 volts. The resistance of the wire is 4.5 ohms. Therefore, 4.5 times 2 is 9. So this is going to be 4 amps of current. And here is the solution. How much voltage will produce a 0.3 amp current through a 120 ohm resistor? All right, so we start with Ohm's law, and we are going to solve for delta V. Delta V equals I times R. I is 0.3, R is 120. 30% of 120 is 36 volts. And here is the solution. What is the resistance of a rheostat coil when 12 volts is applied and 0.04 amps of current flows through the coil? So what is resistance? Well, we start with Ohm's law and solve for R. So first we're going to cross multiply to get the R into the numerator over here. Then we're going to divide by I, and it cancels over there. We get delta V over I. Now we plug in our numbers. 12 divided by 0.04, and the answer is 300 ohms.